Our experimental question this week is, does increasing the number of coins the container holds affect how fast it moves? This is an experimental question because it contains both the independent and the dependent variables of the experiment. So remember that the independent variable is the thing that the experimenter changes on purpose. So in this question, does increasing the number of coins affect this other thing? We are going to be increasing the number of coins the container holds. So my independent variable is number of coins in the container. And whenever you write a variable, you have to include its units. But in this case, number is the unit. Now the dependent variable is the thing that depends on the independent variable. It's what changes as a result. So in this question, does increasing the number of coins affect how fast it moves? How fast it moves is going to be the dependent variable. So how do we measure how fast something is? With its speed. So speed of container is our dependent variable. Now we have to include units. Speed is always measured in distance divided by the amount of time it takes, or distance per amount of time. Miles per hour. How many miles can you go in 1 hour? Kilometers per second. All of these are different speeds. Now in this experiment, you're going to be measuring the number of seconds it takes for the container to travel 50 centimeters. So if it's distance divided by time, this is centimeters divided by seconds, because it's 50 centimeters in some unknown amount of seconds. So our units are centimeters per second. We write that like this: cm for centimeters, a dash which shows divided by, we say this as per, and then s for seconds. So speed of container, centimeters per second, is our dependent variable. Now the constants, or the control variables, are all the things that you're going to keep exactly the same between every single trial. So you're probably going to be using the same setting on the fan or the hair dryer, so you have the same amount of force. You definitely want to use the same container each time, otherwise it's not a controlled experiment. And you also definitely want to be measuring the same 50 centimeters distance each time. You could come up with all sorts of different constants, control variables. All great hypotheses have two parts. One, a prediction, and two, an explanation for that prediction. We've been working on data tables for a couple of weeks now. And one of the things we learned is that your first column is always your independent variable. In this experiment, that's the number of coins. Every other column is your dependent variable, which in this experiment is the speed of the container. So in order to add another column, you right-click anywhere on the table, or control-click, and then select Insert Column Right, because we want this independent variable to stay all the way to the left. So new column, and my dependent variable is speed of container. My units are centimeters per second. Great. But this experiment requires that I run 3 trials for each of the different masses. So I'm going to call this one trial 1, and then add another column for trial 2. So right-click or control-click, insert column right, speed of container, centimeters per second, trial 2. And one more column for my third trial, speed of container, centimeters per second, trial 3. Now, it's always a good idea when you're comparing data to get some sort of average or analysis at the end. So I'm going to add one final column and call this average speed in centimeters per second. Great. So these are just the headings. I don't actually have any cells to input data in. So let me think about how many rows I'm going to need. The instructions say that I'm supposed to try this with 0 coins, then add 3 coins, and then add 6 coins. So that is 3 different conditions I'm going to be testing. So that means I need 3 more rows. So right-click or control-click anywhere on the table, insert row below, and don't worry that it's taken you off the page. We can fix that later. Insert another row below, and insert one final row below. Ooh. Okay, so now I find the bottom and drag it back up to the page line. Great, now I've got my 3 rows ready to go. I'm going to do some quick formatting. Perfect, ready to go. So my number of coins, in my first condition, there are no coins in the container. My second one, there are 3. In my third condition, there are 6 coins in the container. Now in the data table, it's asking for speed, but the thing I'm actually measuring in my experiment is time. How many seconds does it take for the container to travel 50 centimeters? So here's how you're going to figure out the speed. You're going to say, well, the container traveled 50 centimeters in however many seconds. So let's say in this first trial it took 10 seconds. That's 50 centimeters in 10 seconds. In order to figure out speed, you always just divide distance by time. So 50 divided by 10. So that means my answer would be 5, and then since it's centimeters divided by seconds, centimeters per second. So that is the speed of the container if it took 10 seconds to go 50 centimeters. It's fine to put all your work in these cells, just please delete it once you're done so that you turn in a clean data table with just one bit of information in each cell. And of course, I would never leave units in each of these cells. So let's say in my second trial, it traveled 50 centimeters in 25 seconds. Okay, so that's going to be 50 centimeters divided by 25 seconds, which gives me 2 centimeters per second. I erase the work, and since my units are in the heading, I get rid of them down here. And the last part of this experiment is writing up your conclusion as claim, evidence, and reasoning. You can rewrite the claim or just throw in an ending down here of saying whether the speed increased or decreased after all. For evidence, I want you to start off with one sentence that describes how this experiment worked. So to test my hypothesis, I added coins to a container and measured how fast it traveled with the same amount of force. Then you can go into actual specific evidence from your data table. So I noticed that with 0 coins, it traveled at an average speed of 5 centimeters per second. With 3 coins, it traveled at an average speed of 30 centimeters per second, whatever it is. And then finally, your reasoning. How do you make sense of the results that you got? Why does the speed change the way it does when you increase the mass? And then once you're done with that, you're done with this experiment.